Hey, welcome back guys. Today I'm going to show you how to solve two equations simultaneously. Simultaneous equations, I'm going to show you a very short method to perform this type of operation. Some of you might be used to the other methods. You can use whichever method, be it substitution or be it elimination. Any method would work. What I'm going to show you here is just a shorter approach. Let's start with a simple question. The question would read, solve for x and y, which naturally would mean that I have two equations. In this aspect, 3x plus 7y is equal to 27 is equation number 1. 5x plus 2y is equal to 16, which is equation number 2. I need to solve for x and for y. The method that I'm going to use is somewhat different, but once you get the hang of it, you will have no problem. I will ensure that I have my x values first, my y, and then the constant for both equations. It makes it easier to work with x, y, and then your constants. In order to solve, I will start to solve for x. X is equal to, I'm going to introduce you to a very simple method of doing it. Some of you who have further just studies in maths would say, but wait a second, I know this is another section totally, but for this level guys, just follow the sequence. I am going to have something multiplied by something, or the product of two numbers, and then I'm going to signify this as being the difference. It's always a negative sign in the middle. Now as I go further, you will see what I mean. I'm going to start off with this 7 as my reference point. I'm only dealing with the coefficients. Multiply across. Remember, this is not cross multiplication guys, so I will go and say 7 times 16. 7 times 16. I start populating this equation that I have on the top. The next step, once I finished off with the 7 times the 16, I go across and I will take the 2 multiplied by the 27. So 2 times 27. Remember, I've already done 7 times 16. Now it is 2 times 27. I put that as my numerator. In order to fill in the denominator, I still use the 7 as my reference point. But I'm going to multiply the opposite way. I will start off by saying 7 times 5. And in order to get the last part of my denominator, I multiply whatever else is left, which is the 3 multiplied by the 2. And 3 times 2 is 6 at the bottom. Now guys, just to recap, 7 was my reference point. I multiplied across 7 times 16. Then I go 2 times 27. How's that guys? Simple enough. Once I finished off with that approach, the next approach that I used, let me just change the color, point to options, in color, let's go with a different color. In order to get the denominator, what I did was I used the 7 times the 5, and then it was the 3 multiplied by the 2, and that will lead me to the denominator. Simplifying this further guys will give me 7 times 16, which is 112, 2 times 27, which is 54, 7 times 5 is 35, 3 times 2, which is 6. And simplifying that even further is 58 divided by 29, which we all know is equal to 2. For the sake of time guys, I'm going to rush over to solve for y. Once I've solved for x, I'm going to use the value that I've obtained in x to get now the value for y. Next step, to solve for y, I have to substitute x is equal to 2 in any equation. For simplicity, I'm going to choose equation number 1. Equation number 1, wherever I see an x, I'm going to replace it with 2. 3 times 2 plus 7y is equal to 27. That's 6 plus 7y is equal to 27. Move the 6 across. 7y is equal to 21, and divide by 7, you get an answer y is equal to 3. And now guys, by doing that simple method, I have solved for x, which was equal to 2, and I've solved for y, which is equal to 3. Be very careful if these signs are negatives, or if any sign is negative, carry the negative sign back into the given equation. Thank you guys. I hope this helped you.